Hello, my name is Jeff Dunn, and I am a watershed hydrologist with WGM Group in Bozeman. My talk is entitled Water Budget Analysis for a Rapidly Developing Headwaters Community, West Fork Gallatin River Watershed, Big Sky, Montana. And this project was done for the Gallatin River Task Force. So why develop a water budget? First, to enhance our understanding of the water supply, we have a recreation-based economy, including fly fishing, to help identify and implement actions to conserve and restore the ecological health of the river systems. So the West Fork Gallatin River watershed pictured here on the right includes three main subwatersheds: the South Fork, West Fork in yellow, the Middle Fork, West Fork in green, and the North Fork, West Fork in pink. These two flow together to make the Upper West Fork, and the West Fork proper really just accounts for this small section in red. There's also the task force maintains 4 gauges on these tributaries, and as well as 2 USGS gauges on the main stem of the Gallatin River and the Lone Mountain Snowtail site up on the mountain. All right, the West Fork Hydrologic Cycle 101. Our inputs include precipitation in the form of snow and rain, outputs, atmospheric loss, such as evapotranspiration and sublimation, our stream flow, and our infiltration with shallow groundwater and deep groundwater. A schematic showing these processes occurring on the landscape: precipitation coming in, evapotranspiration and sublimation going back into the atmosphere, and the shallow and deep aquifer inputs down here. All right, looking at the Snowtail data from 2006 to 2022, snow shown to the peak SWE in light blue, and then rain in the darker blue. You see in the year 2011, we had our greatest amount of precipitation as well as the greatest amount as snow. 2015, we had our lowest amount of snow and kind of 50-50 rain to snow ratio. All right, looking at the watershed, we have 53% of the area above 8,000 feet that accumulate 73% of the snow. And you see that depicted here in pink in these higher elevation areas as the snow accumulation spots. Also graphically, snow accumulates kind of from November through April, and then it transitions to that rainier time of year. All right, looking at our water yield outputs, North Fork in pink providing the smallest contribution of stream flow, joining the Middle Fork, which is larger, to form the Upper West Fork here in blue. The larger South Fork, West Fork comes together, forms the West Fork proper, as we see here in red. As we flow into the main stem Gallatin River, the West Fork makes up 20% of the flow at the Deer Creek gauge and 14% of the Gallatin River's flow here at the Gallatin Gateway gauge. Looking at the annual water budget, we have snow as our primary input along with rain. Outputs, evapotranspiration and sublimation leading the pack of outputs, followed by stream flow and melt-related runoff and shallow infiltration, which combined make up stream flow, with this shallow infiltration being our base flow. Deep infiltration dropping out of the watershed here at the bottom, and then a small proportion of the watershed or overall water budget being comprised of human use and reuse. Looking at this schematically with one snowflake representing a mean annual precipitation of 10,000 acre-feet and one fish representing mean annual stream flow of 10,000 acre-feet, with the South Fork, West Fork in yellow being the largest, accumulating the most snow, providing the most stream flow. The North Fork, West Fork is the smallest, but comparatively to its size, relatively, it accumulates the most amount of precipitation, and you can see that with the high elevation peaks backing up there in the Spanish Peaks area. Total output for the watershed: precipitation coming in, 137,000 acre-feet, 66,000 going out, or roughly 52% of our precipitation is realized as stream flow. All right, you want to save on your water budget? Things that do it naturally include the beaver dams on the landscape and the meadow ecosystems, and logs and log jams and cascading pools in the more steeper mountain reaches. Now, management recommendations that came out of this were to improve the monitoring network to get better data, slow the flow through the drainage network, and optimize water use and reuse. You can see here on the right a project implemented by the Gallatin River Task Force in partnership with Trout Unlimited to slow the flow, spread that water on the floodplain, which you see in these pictures here. And with thanks to everybody. Thank you.